Hi, in this video we're going to talk about critical points of functions. So a critical point of a function is a point where the first derivative of the function is going to equal 0 or will be undefined. So let's take a look at some of these examples here. Find the critical points of this function. So what we need to do is find f prime. We're going to have to use it's power rule and chain rule. This is what we're going to end up with, and then we set it equal to 0. We know it's a linear function, so there is no point where it's going to be undefined, but this is going to give us x equals 2. This is where we're going to have a critical point or a critical value. This function x cubed minus 2, so we find the derivative, which is going to be 3x squared. We're going to set it equal to 0, and it's going to give us x equal 0. It's a little tougher here. These functions are not exactly the easiest ones to differentiate, but you may remember what we have here is a function that looks like this. This is 4. So if you actually attempt to take the derivative here, you can write it as a piecewise function. It's going to be -1 when x is less than 4, and it's going to be +1 when x is greater than 4. So that means that this function is going to have a derivative that's undefined at 4. That makes it a critical point. And you also can see from the graph that there is a sharp turn, which is something that would support that claim. Moving on. This example 4. So we need to take the derivative here. So I would probably rewrite that as 2 times x plus 5 to the power of -1 before you differentiate that to make it easier. This way you don't have to mess with the quotient rule. So f prime of x is going to be -2 times x plus 5 to the power of -2, which is -2 divided by x plus 5 to the power 2. And this will never equal 0. So you don't have this point, but this derivative does not exist when x equals -5, so that makes -5 a critical point. Now we have some piecewise functions that we have to look at. So let's try to figure out the derivative here. So the derivative here is going to be 2x. When x is less than, we don't know if it's going to be equal to 1, we have to wait. And over here it's going to be 3 when x is greater than 1. So on one side of 1, the derivative is going to equal -2. On the other, I'm sorry, +2. And on the other side of 1, the derivative equals 3. They don't equal each other. That means f prime does not exist. Prime of x does not exist at x equals 1. That means that x equals 1 is going to be a critical point. Let's try to do it with example 6. So f prime here is going to be, we differentiate this quadratic, so that's going to be -2x plus 4 when x is greater than 0. Over here it's going to be 4 when x is less than 0. We have to check for equal. So what's going to happen? At 0, on this side, the derivative is going to equal 4. On this side, the derivative is always 4. That means that here, you can actually have equal. So the derivative to the right of 0 is going to be -x plus 4, and to the left of 0 is going to be 4. But they are actually going to equal to the left and to the right of 0. So it's not the same situation that we had here. However, you have this part of this expression where the derivative can equal 0, and that is when x is 2. So that is going to be our critical value or critical point. Let's take a look at some of the graphs. So we're looking at the graph of a function. We're going to try to see if we can figure out critical points. So critical point is where the derivative is 0 or does not exist. That means if the derivative is 0, you have a horizontal tangent line. So if you visualize a tangent line be drawn to that graph, you are actually going to have a horizontal tangent line at this point. which resembles the vertex of the parabola. So here you're going to have a critical point at x equals 3, because the derivative here is going to be 0. Example 8. So there is no point where the derivative is going to be 0, because there is nowhere where you're going to have a horizontal tangent line, but right here you have a vertical tangent line, which means the derivative here fails to exist. So at x equals 0, this function is going to have a critical point. A couple more examples. So where do we have critical points here? Well, here we're going to have critical points at all these sharp turns, because what happens at these sharp turns, the derivative changes abruptly from one value to the other. If you think about the slope of this part here, it's 0, but this here is -2, so it abruptly changes from 0 to 2 to -2 at x equals 2. It also changes abruptly from -2 to +1 at 4, and it also changes from 1 to 0 at 8. So this point, and this point are all going to be critical points, because the derivative there is actually going to fail to exist. Okay, so we're going to have x equals 2, x equals 4, and x equals 8. We also have this part here where the derivative is going to be 0 the whole entire time, but at this point we're not going to be interested in this. And finally, let's take a look at example 10. So what are we looking for? We're looking for some kind of a function that's a curve, and we have some points where the derivative is going to equal 0, and those are the points that we are interested in. It doesn't look like we have any sharp turns here, so we have a horizontal tangent line here, also here, also here, and also here. So all 4 of these points is where the derivative is going to equal 0. Again, it does not look like we have any points where the derivative fails to exist, which means we are looking for a sharp turn. So what are these points? It's x equals -10, it's x equals -7, it is also x equals 0, and it's x equals 4. Okay, and that's all.